this is Anjali, and in this video I'm going to explain you how to solve question number 3 for computer science class 12th exam. And this paper is specifically the question paper of 2017 board exam. We've already discussed question number 1 and 2 in the previous videos, and now I'm going to start with question number 3. As I've told you earlier, that question number 3 is for 15 marks. It carries questions which comes from arrays, matrices, and data structures. So usually there are 5 questions which might carry 3 marks each, or there could be one question for 4 mark, one for 2 marks, something like that. But in total, it will be for 15 marks. There would be one program for arrays, one for matrices, one question to solve the address of a matrix. Then there is a one numerical on data structures and one program on data structures. So let's start with it. The first part over here is a part of question number 3, which says write the definition of a function add up, which receives an array and its size as arguments in C++, in which all even positions of the array should be added with the content of the element in the next position, and all position elements should be incremented by 10. So read the question properly, because while solving you must have a very good understanding of the question beforehand. So what it says is that the elements which are at even positions, they have to be added with the next element and has to be stored back at the original position. Whereas the numbers at odd positions have to be increased by 10. For example, they've given an array that the original array is this, like 23 is at position 0. That's an even position. So we're going to add it with the next element, which is 30. That becomes 55. And that becomes 53, sorry. That becomes a new value for position 0. Then 1 is odd, so 30 is just incremented by 10 and it becomes 40. Then we have the next position, which is 45. And if I add the next value to this, it becomes 55. 10 plus 10 is 20. Then 15 plus 25 is 40. But 25 plus 10 is 35. So if the position is even, I have to add the next one and store it back in that even position. And for solving this question, they have given you some notes as well. That is, the function should only alter the content in the same array. That means you cannot take any extra array. The function should not copy the altered content in another array. The function should not display the altered content. So that means you just need to modify the array, but you don't have to print it. And assuming the number of elements in the array is even. So we don't have to put a condition to check whether the number of elements in the array are even or odd. We know in advance that it's even. Okay, let's start with the thing. So the first line is your function prototype. So I'm going to write there. First line says void, means I'm not returning anything. Add up is name of the function. We're receiving the array and its size as arguments to the function. So what I need over here is I need a variable I for the index. And then what are we supposed to do over here is to have a loop. So we take a loop which starts from 0, goes up to n, and we need to increase I by 2 every time. Or you could check inside the loop for even or odd position, or I can just increase it by 2. That's up to you, whichever type of logic you want to have. Now what I'm going to do over here is I'm going to change both the positions over here. So what I'm going to do, ARRI should be ARRI plus ARRI plus 1. That means we should add the element at position I with the next element and store it back in ARRI, and the next element should be increased by 10. And that's it. So this was the code. So how does it work? For example, we had 6 elements, and this example, I is 0, I less than 6 is true, it comes here. We know 0 is even position, so A00, that is, sorry, ARR0 and ARR1 are added and stored back at ARR0, which gives 53 here. Then ARRI plus 1, that is ARR1, is increased by 10, so which gives me 40 here. Then I increases by 2, I increases by 2, and it comes here. So ARR2 will be 2 plus 3. Then I get ARRI plus 1, which is 3, that's increased by 10. then it becomes 4, and similarly 4 and 5 index are added and stored back at 4, and this one becomes 5 now. So 5 plus 10, that means whatever value is there at index 5 plus 10 comes over here. So one way is this, or this loop could be written in one more way. I'll just show you that. Or this answer is right, or if you write it this way, where I take this as plus plus, then inside this I had to check if I mod 2 is equal to 0. That means if I is even. If I mod 2 is equal to 0, we have to perform this, else then I will not write this, I'll write AI. So if I mod 2 is 0 means if it's even, then we should put ARRI as ARRI plus ARRI plus 1. That is the number and the next number. But if it is odd, we should just increase it by 10. So you write this or you write this. Both answers are correct. To make your answer look better, you can try giving comments in this. For example, I can write here changing, or you can write over here changing the value at even position. This is a comment here, and similarly I can give a comment here, that is changing the value at odd position. Always remember, when you write comments in your code, use a black pen or a pencil to write the comments, and obviously you have to put the double slashes, and if you have more than one line of comment, then put it in slash, star and star slash. So this would be your answer for 2 marks. And comments always make your answer more presentable. So wherever you feel like, you should give comments in your answer. Okay, that was A part of question 3. Now comes B part of question 3. That is a program related to matrix. It says write a definition for a function sum mid call, which receives a matrix n and m for the number of rows and columns in the matrix, which finds the sum of the middle column element of the matrix, assuming n represents number of rows and m represents number of columns, which is an odd integer. Again, they've told it's an odd integer, so we don't need to check for that. Now, for example, if the content is this is a 3 by 5 matrix, I have to add the middle column. So I have to add the middle column and show the sum. Good enough. So we start with the code. Our code says void, then name of the function, that is sum mid column, and you're going to receive a matrix over here, and we're going to receive the number of rows and number of columns, and inside this we're going to code for it. So I have to take I and j. Since we don't need a loop for column over here because column is going to be fixed, column has to be the middle column always. So for that, j should be taken as number of columns divided by 2. So this gives me the middle column. J is equal to m by 2. So j becomes your middle column, and for all rows we have to find the sum. So the loop should go for n times like this, and inside this we've taken a variable for sum, and we're going to add sum plus equal to matrix ij. So where I and j are going to remain same, I will change, j will remain same, and once we are out of the loop we can print the sum. That's it. So this answer is for 2 marks. So I knew that the column is fixed. For example, here it was 3. So 3 upon 2 will give you 1. So j becomes 1. But the loop for I goes from 0 to less than n. That is from 0 to less than 5. So it adds matrix 0, 1, then matrix 1, 1, matrix 2, 1, matrix 3, 1, and matrix 4, 1. And finally, whatever you get becomes the sum, and we print it at the end of the loop. So that's how we answer for the matrix. Then comes your question number C, which is for 3 marks. Now here we have ARR 1520 is a 2D array which is stored in the memory along the row with each of its elements occupying 4 bytes. Find the address of the element ARR 515 if the element ARR 105 is stored at the memory location 35,000. So now what all is given? So first of all, in such questions we should write what is given. So given is number of rows, which is 15. We are given the number of columns, which is 20. So I have maximum number of rows as 15, columns as 20. It's a row measure matrix and the width of a single element is 4 bytes. We have to find the address of ARR 515. This has to be found if the element at ARR 105 is stored at the location 35,000. Okay, fine. So sometimes when you don't have the base address, but you have to find the address of some other element, if it would have been asked in the question, like find the base address as well, then first using this address, we will calculate the base address, and then using that base address, we can find the address of 515. But since base address is not asked, we can directly find 515. Although I'll tell you both ways to do that. So first way is, let's say, with the help of base address. So we don't know what base address is. First we need to find the base address. For that I take I as 10 and j as 5, which is the address we already have. Okay, as per that the formula becomes that any address is equal to base address plus, it's a row measure matrix. Since it's a row measure matrix, so it should be number of columns multiplied by the number of rows which we have crossed plus j, that is the number of elements in the current row, this whole multiplied by the width. Okay, so base address we don't know, but we know the final answer is 35,000. So we don't know the base address plus. Now C is, in this example, 20. That is maximum number of columns. I is 10. So I have to do 20 into 10 plus J, which is 5. This whole thing multiplied by the width. So this whole thing we have to multiply by the width. So that turns out to be base address is equal to 35,000 minus 20 into 10 is 200 plus 5. 205 into 4. 205 into 4 is 820. I guess I'm right. Yeah. So base address comes out to be 34. That should be 180. Yeah, 34180. So that comes out to be the base address. So we have found the base address. Now we need to find the address of 515. Since we have to find the address for this, again we have to put the same formula. So if I put the same formula here, and this time the base address is 34180 plus, we have to do C, which is 20 into I. Now I is 5, that is the row number which we have to find the address for. That's I, plus J, which is 15. This whole thing multiplied by 4. So that is 34180 plus 20 into 5 is 100. That becomes 115. 115 into 4. So 34180 plus 30, that becomes 460. Yeah, it becomes 460. And let's add this. So what should we get? it should be 0, then 4, then 6, and then it should be 4, 3. So I hope I'm calculating it right. So it should be 34640. That should be your answer. So this should be the answer with this particular method where we found the base address first, and then using that base address we calculated the address of A515. But there is one more way of doing it. That one more way which I was telling you is where we take this address, the ARR 10.5 address, as the base address. So if I assume this one to be the base address, then I have to consider the lower bounds. By default, lower bounds are considered as 0, 0, lower bound for row and lower bound for column. But now you have to take lower bound as 10 because the address given is for ARR 10.5, and lower bound of column should be 5. And then I have to find for 515, so I should be 5. J should be 15, number of rows is 15, number of columns is 20, and width is 4. So all this is given. So we have these as given value. And now I'm going to write the formula and calculate the stuff. So how are we going to write the formula now? So the formula should be written as base address plus, initially we had column into I, but now it should be I minus lower bound of row plus j minus lower bound of column into width. So we do it this way. So base address you have is 35,000 plus C is 20 multiplied by excuse me, I minus LR. I is 5, LR is 10. So 5 minus 10 is minus 5 plus J is 15 and LC is 5. So that is 10, and this whole thing multiplied by the width. Okay, so 20 20 into minus 5 becomes minus 100. Minus 100 plus 10 becomes minus 90, and minus 90 into 4 becomes minus 360, and that gives me 34640, which is the same as we got from the above technique. So you follow any of the two techniques, your answer would be same. So just to repeat, in the first method, we first found the base address using the formula, putting in the values, and using that base address, we calculated the address of 515. So this is a longer method, but this is one of the techniques you can do it. But if you don't have to find the base address, we can do it with the help of this shorter formula, where we can use the lower bound of R as the address given for the particular position, and we can use the lower bound of column for the particular positions. So that's how address can be calculated, and the question for address calculation comes for sure for at least 3 marks. So it's just a numerical. Remember the formula, put the values properly, and do the calculations. That's it. No programming required for this question. So that's for 3 marks, question number C of question number 3. Okay, then comes the D part. D part is basically related to data structures, D and E, both of them. One of them is a numerical and one of them is a program. So this program is for 4 marks. It says, write the definition of a member function push gift for a class stack in C++ to add a gift in a dynamically allocated stack of gifts considering the following code is already written as part of the program. Okay, so it's already given. Now we have to write that code. So write the definition of a member function. You have to write for the push gift for a class this thing. So I have to write this. How would you start with it? We'll write void name of the class, which is stack. Then you write scope resolution, and then we write name of the function, that is push gift, and the round brackets, and over here we need to start with the code. Now, what we have to do in this is we have to insert the value of a gift that consists of a gift code and a gift description. This is your linked representation of creating a stack. And in stack, when we insert, it's always inserted at the top. So first of all, I have to take an object of type gift. Then I need to take a pointer of type gift again. So I take gift star temp, let's say. Okay, we don't need an object in this one. We can just do with the pointer. So we just take a pointer and I need to allocate the memory. So I write tmp is equal to new. New is the keyword, and then you have to write the class name. So it allocates the memory. When it allocates the memory, you get three things in it. That's G code, G description, and the link. Then I ask the user to input the values. So we ask the user like enter gift code, and when you have to enter the gift code, we have to write here cin for that. So cin will help you to read the gift code, and that gift code we need to read with the help of tmp arrow G code. When we have an object, we put a dot, but when we have a pointer, we're supposed to write arrow, that is in direction operator for the same purpose. So we read the value. We have enter description, then you have to write cin tmp arrow G description. So we read this. Now we have created the node. Now the thing is to link this node with the existing stack. And initially I put null in the link part. So I've created a new node. The only change which you make in the push function is the input, the different values which you have to input. Rest of the code always remains the same. There is no difference. What you have to do in rest of the code is you need to check that if top is equal to null. Yes, if top is null, then what I have to do is I have to put this temp in top, and that's it. My thing is done. I'm done with the code. Else, if there is something in the stack, if stack already has some values, then what I'm supposed to do? Then what I'm supposed to do is I have to put this new node on the top of the existing stack. So the link part of temp, the link part of temp should point to the top, and the top should change. The topmost node should be the new node now, so top becomes tmp, and then we close the bracket for else and we close the bracket for the function push. So that's how we write it. So if you ever notice, the code for push and pop always remains same. The only thing that change is the values which you have to store. Otherwise, the code for push is always this, that you check if top is equal to null, you put temp in top, else temp link will point to top and top changes to temp. So this code never changes. What changes is which values you have to input. So that's how we push. And similar is the way pop when you delete an element from the stack. Now to go to the detailed thing that how push and pop works, you have to go to my video which explains what is stack and how we can perform operations on stack or queue. Okay, but this question comes for sure in every exam. Maybe you have to write for push, you have to write for pop, or you have to write to insert in a queue or delete in a queue. That's your D part of question 3. Then finally we have E part, that is the fifth part of this question. And in this fifth part, they have given us an infix expression, like convert the following infix expression to its equivalent postfix expression showing the stack contents for each step of conversion. Now for this, I have to treat each and individual character. So what I'm going to do is I'm going to make 3 columns: infix, stack, and postfix. So in infix, I'm going to write the character which I'm going to scan one by one. So the first character is X, Then the next character we have is minus. The next character we have is the opening bracket. Then we have y. Then I have plus. Then I have z. I have closing bracket. I have division sign. Then we have u, multiply, and v. Okay. So we have all these symbols now. Now let's see how do they work. Whenever you have to convert infix to postfix, the basic rules are that whatever is the alphabet that directly goes to the postfix expression. So x comes directly over here. Whenever you have an operator that goes to the stack, and for that we have certain conditions, like if stack is empty, then whatever it is, it will directly go to the stack. You don't have to do anything for that. Then comes the bracket. A bracket also always goes in the stack on the operator. So bracket comes here, whereas the postfix remains the same. Then comes y. Now since it's y, it is an operand, so my stack remains the same and y goes to the postfix. Then comes plus. Usually we cannot have operators of the same level in the stack, but here we can get plus because there is an opening bracket in between. So we can put plus over minus because there is a bracket in between. If we don't have that bracket, then minus has to be popped from the stack and shifted to the postfix place. But in this case, nothing will happen since there was a round bracket in between. Then we get Z. So we have this again as it is. And here we get X, Y, Z. Then I get closing bracket. Now when a closing bracket comes, you have to pop the operators from the stack till an opening one is found. So we are going to pop plus, and that plus moves to the postfix. So this plus is popped from here and goes over here to the postfix. Then this round bracket, opening round bracket, is popped from the stack, but it doesn't go anywhere and it stops. So closing bracket works till you find the opening bracket, and all the operators in between are popped out to the postfix. So it moves here. Then it comes to the next operator, that's divide. Divide has a higher precedence than minus, so we can put divide over minus. Now on the stack top we have divide. It is possible. Then you get u. Then I get u. Stack remains same, and over here you get u in the postfix. Then you get multiply. Now multiply and divide can't be there together. So divide, because they're of the same level, then divide has to be popped. Divide will be popped and divide would go to the postfix. So my postfix expression would be this now. So divide from here has been popped and it moves to the postfix over here. And now multiply could be pushed here because you have minus and multiply has a higher precedence than minus. Then comes v. Now when comes v, the expression gets v also along with it after divide. Now my infix expression is over. Since my infix expression is over, I'm going to pop all the operators, and first multiply will come out and then minus will come out because the topmost thing is deleted first and then the second one. So we get this, and this is your result or the answer for the postfix notation. So this is resultant postfix for the given infix. So your answer is x, y, z plus u divide v multiply equal to. You can cross check it, like it will first add y and z. Y plus z will be done first. Then whatever will be the sum, that's divided by u. And then that thing is multiplied by v. And finally the subtraction will take place as per the precedence of operators. So this question is for 2 marks. Or the other type of question that comes as evaluation of a postfix notation, which could also come, that's also an easy numerical. So this is how your question number 3 is formed, with questions from arrays, matrices, and data structures. And it gives you a weightage of 15 marks, which is too much to score. So prepare for this well, and the pattern never changes. The pattern is all same since many years, and it's expected to remain same. Hope you understood how I solved this question. If there is any doubt, do write in the comment section below, And I'm giving the links to download the solution as well as the paper in the description section. So you can download the solution as well as the paper from there. Do write to me for any other questions for which you want solution. Thank you. Keep watching, keep learning, and yes, don't forget to subscribe the channel so that you keep getting the updates. Thank you.